Hey fellow YouTubers, this is N0AGI. It's been a while since I did a YouTube video. Been busy with work, quite a bit of travel, so couldn't really find any time to my hobbies and such. And any little time I had left to myself, I was able to spend a little bit of that with the family and whatnot. So got sucked into a lot of things, so got a little busy with work. Anyways, so I had some time briefly, so I thought I'd do a short video on a project that I've been working on. You must have seen my previous videos on these NIXIE tubes. These are IN12s. These are IN12As. And I'm a huge fan of these NIXIE tubes. Very nostalgic, brings back a lot of memories for me. But anyways, so I started working on this project. This is a single NIXIE tube clock, and what you're seeing in front of you is a quick show of time, and really it's driven by a few components here. Let's start with left to right, maybe that might be useful. What you're seeing here is a breakout board I made using this prototyping board from eBay. I got a few of these from eBay a few months back, and so I made this prototyping board, or a breakout board, for this IN12A. What you're seeing there is the K155ID1, I think it is, the chip. It's a high power, rather high current and high voltage NIXIE driver chip. You must have seen that in my previous videos also. And the board itself was prepared just so to save me some time, because I'm working on a few projects using NIXIE tubes. And every time I build a project, I'll have to kind of rewire. I end up rewiring the NIXIE pins. There are about 10 pins in the back. I would end up rewiring those and connecting them with this driver chip and whatnot. So there's a lot of repeatable kind of wiring that I end up doing. So what I thought was, maybe I'll just build a breakout board for experiment. And that's what you have here. So what it breaks out is 7 pins up here, and the 7 pins correspond to 0, the 4 bits that correspond to the decimal number, the 4 bits, the 5-volt supply for the driver chip, a ground pin for the common ground, and then the high voltage 170 volt supply to the NIXIE tube. So really there's 7 pins that are breaking out from this prototyping board. And I'll give you a close-up view of this. In fact, what I will end up doing is showing you how to build this yourself in a step-by-step manner. But in this video, I'm just going to cover quickly what this contains. What you have here, this is a miniaturized version of the high voltage boost chip. So it takes a 5-volt input and then puts out a 170 volt output that's used by the NIXIE tube. Now behind this proto board and the boost circuit here, there is I believe a 100K resistor that's in series with the 170 volt supply going to this board, just to limit the current going to this. Because if you don't have that resistor, what I've seen it do is the NIXIE tube gets really hot, obviously, because there's more than enough current flowing through, and the tubes don't like it. But more importantly, also the driver chip dies on you really fast. So I put that 100K resistor, and that took care of the problem. So this is the boost chip I got on eBay. I think they go for $9.99 compared to whatever the other ones. They go for like 49 bucks. They're a little bit bigger than these guys. Let me actually show you how the other one looks. Okay, so here's the other larger board I also got from eBay. This goes for 49 some bucks. I wish I had known about these smaller ones before, but anyways, I ended up buying this from NIXIEClock.org. They actually work pretty good. Definitely much more robust and well made than these $9.99 ones, but you could actually drive up to, I think I've seen somebody do up to 12 NIXIE tubes with this one chip, which is plenty for me. So anyway, so this is the 49 bucks one, and here's the little one that's on the board there. This is the 999 version of that. Not the best fabricated chip in the world. I'm having a tough time focusing this. Let's see if I can, yeah. So, but still it works just fine. Not a big deal. Okay. All right, we'll take a closer look at this when I show you how to build this yourself in the next series of these videos here. So anyway, so those two are the boost boards. So that's $9.99 board from eBay. Anyway, so that's the chip that powers the NIXIE tube, and it also provides. Well, it takes a 5 volts from the USB here. This chip here, that is the shift register, the 74HC595. And what it does is it takes a shift out command and the bits, the bytes from the Arduino, and then puts out the corresponding binary for this board here. So this guy, the 595, takes the four bits that correspond to the decimal, and then converts it to decimal and drives this guy here. So it's a shift out register, and you will see more details on that in my follow-up videos here. And this is the Arduino Nano, and you could actually, I bought these on eBay. I don't know how much I paid, but nowadays you can get one of these for like $4 or $5. Not the original Arduino versions, but the Chinese versions for like $3 or $4. They work just fine. I've seen some videos. Somebody was doing a walkthrough of it. That seems to be working just fine. So I might actually buy a few to do some experiments with it. This guy here, let me actually see if I can tilt this a little bit. This is the RTC DS3231. That's a real-time clock, which is driven off of I2C protocol. And the I2C is provided by the Arduino Uno through these two pins here. And this chip needs the clock and the data pin from I2C, and of course it needs the ground and the 5 volt supply. And this the 595 chip requires the ground and the 5 volts that are coming from these two connectors here, and then the 3 pins coming out from the Arduino. One is a latch pin, well, one is a clock, one is a data, and the other is a latch pin. So those 3 go into the 595, and the whole thing is powered by a wall wart USB adapter. So really that's it. And what Arduino does is it grabs at the startup, Arduino grabs a time from the RTC, and if the RTC time is invalid, then what it does, it sets the system time. And system time is usually available when you're programming the Arduino from your PC. And at that time, the date and time global constants become available, or global variables become available. And that gets set as a current time and date to the RTC chip. And every time thereafter, the RTC chip should be up to date with the time, because it's got an onboard battery here. Let me show you. There's the onboard button cell. And it keeps time, and then Arduino reads the time and then parses out the hour and the minutes, converts that to a byte format, and then shifts out the byte into the 595 through these pins here. 595 then converts the byte into the shift out bits, which correspond to the 4 bits. The first four outputs here, as you can see, these blue wires, and this blue wire here, that's a bit 1, and then 2, 3, as bit 1, 2, and 3 and 4 are here, and those 4 bits get fed into the input for the breakout board, and that then gets converted by, or rather, that gets fed through by the driver chip into the tube. So it's actually fairly straightforward. It's nothing complicated. So what it's showing you right now is the weekend, whatever, Saturday, Sunday, whatever. So it shows the current time, and then, for example, 153 322 3:22 in the afternoon. That's the current time. Now I've added some code in the Arduino to do that wobble at the end of the display. That's nothing more than just doing a for loop. That does a pretty cool wobble there. So so you will see that code as well in the follow-up video. So anyway, so that's a quick view of the single tube or single NIXIE tube clock using Arduino Uno, the 595 register, the DC to DC boost chip, and the K155ID1 NIXIE driver chip. And of course the RTC DS3231 chip. Now this one here, this is just a push button toggle to cut off the power going to the NIXIE, just to do some testing or whatever. So that's a quick view. Let me see if I can bring it closer. I don't think I can because the USB cable is not long enough. But let's see if I can do a zoom in here, or let's see if I can uncouple this. Okay, that's a quick view. Alright, thanks for watching, and please do look for the follow-up videos on how to make this by yourself using these parts here. So I'll walk through one by one, and we'll build one exactly like this in the follow-up videos. We'll probably start with building this guy here, this breakout board. Alright, thanks for watching, and we'll talk soon.